to list strategies for solving exponential and logarithmic functions. And I had you turn to that page so you could see the kinds of equations I was talking about. Okay. So, who had some ideas? We'll start with exponential functions. Who had some ideas for strategies?
You use like, I don't know what it's called, but where if the base is equal to other than that.
Okay, that is called the one-to-one property. That's what you had to use on your quiz, right? If a to the x equals a to the y, then we know x equals y. Is that what you mean? Okay, good. Other strategies that you wrote down. Henry.
If you wanted to, you can change the form to a log.
Ah. Change to log form. I like it. Any other ideas? What must be true before we can change it into log form?
It has to be that x has to be by itself, or like the x that is raised to be by itself.
Okay, whatever's being raised to a power is maybe how I would describe that, needs to be by itself. So anything added, multiplied, subtracted has to be put over to the other side before we can rewrite it. Okay? Logarithmic. Ideas there. Okay. So change to exponential form, is that what you mean?
Oh, I said change of base.
Change of base.
You could do that.
Okay. Change of base formula. Change to exponential form. Carla, do you have your hand up or was yours?
So I was going to say that change that first.
Okay. What else?
Condensing.
Condensing could be very useful here. Okay. Another strategy. There's one left that you know about. Huh?
See if you can do it with your calculator.
No. And guess and check is not a strategy either. Okay. What if you have a log on both sides? We also have that one-to-one property with logarithms. Okay, so since we have it on the exponential side, we'll have it on the logarithmic side as well. Okay? Basically, if you have an exponential equation to solve, and you can isolate the exponential piece, you can change it to logarithmic form, and that variable is no longer inside of your function. On the flip side, if you have a logarithmic function where the variable is inside the logarithm, you can isolate the logarithm, rewrite it, and then that variable is no longer inside of your function, okay? That's why these two concepts we always learn together, because they are helpful tools to solve the other. Okay, inverses undo each other, right? So we're going to use each of them when we're working on the other type of equation. Okay. Now, if you recognize things like the one-to-one property, okay, those are simple ways to solve a problem if it can be applied, but not all the time can we apply it. Okay, so you'll just have to keep your eye out for if we have things raised to a power that can be written as the same base, because that will help with our solving. So I have 1, 2, 3, 4, 5 problems we are going to do together, hopefully before lunch. I think we can get them all done before lunch. And then I'm going to give you an activity, okay? Basically, you just need to practice doing these problems, okay? And instead of me practicing up here for you, you're going to practice together after lunch, okay? So we will start simple. Two times 5 to the 2x plus 3 equals 32. Okay. our variable is inside of our exponent. Okay. If you saw this problem, Amanda, what's the first thing you would do? I think dividing by 2 would be great. So you have 5 to the 2x plus 3 equals 16. You cannot multiply that 2 to the 5. The 5 is tied to that 2x plus 3 power. Nothing can be multiplied to it. Okay? So we divide the 2 over. Now we have an exponential function. Our variable is inside the exponent. How do we get it so that variable is no longer in the exponent? Caroline? Make it a logarithm. Okay, so we have log base 5 of 16 equals 2x plus 3. Here is why I taught you how to use your calculator for times like this. What you are going to have to do is first plug this into your calculator. So you will evaluate log base 5 of 16 in your calculator. You'll subtract 3, then divide by 2 to solve for x. Okay. So log base 5 of 16 you should be getting like 1.7227 blah 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 blah. Then to isolate x you'll want to subtract 3 and then divide by 2. To 3 decimal places, Ryan, what's our answer? Do you agree with Ryan? There's your answer. What we need to recognize about this problem is that we do not rewrite it as a logarithm until that base to a power is isolated. We have to divide that 2 over because it has nothing to do with the exponent, and then we can rewrite it. Next one. Okay, we have e to the 2x minus 4 e to the x minus 5 equals 0. What does this kind of look like? It kind of looks like a quadratic equation, doesn't it? Okay. So how about this? If I said x squared minus 4x minus 5 equals 0, what would you do? Gabe, you would factor it, is that what you said? And what would you factor it to? X minus what? Okay. Do you agree with Gabe's factor? Okay. So over here, we have a trinomial in disguise, I like to say. It's still following the pattern of x squared minus 4x minus 5, but instead of x, we have e to the x. So this is going to factor to e to the x minus 5 times e to the x plus 1. E to the x times e to the x is e to the 2x. So instead of x squared, we have e to the 2x. Okay. E to the x times 1, negative 5 times e to the x. That gives us the negative 4 e to the x. All right, so now what do we do with each factor? Set each factor equal to 0. Okay, so let's start with this one right here. E to the x minus 5 equals 0. That means e to the x equals 5. Since the x is inside our exponent, to get it out, what must we do? Okay, we need to rewrite it. Log base e of 5 equals x. What does that approximate to?
1.61.
Over here, we have e to the x equals negative 1. Since x is in the exponent, we can rewrite to change forms. Log base e of negative 1 equals x. It doesn't work because it's negative. Algebraically, e to the x plus 1 is a solution, but it doesn't actually give us a value. That might happen where algebraically something works, but it doesn't give you a solution that makes sense, and that's okay. Just cross it out. Don't worry about it. I'm going to skip this one and come back to it. We're going to work on this one. We'll go to a logarithmic function equation. Okay. What do you think? Okay, what do you think?
And I was going to change it to exponential first.
Okay, and how would you do that?
The e to the fifth is equal to square root of x minus 8.
Okay, how do you guys feel about that? Pretty good? Is that legal mathematically? It is, okay? Since the logarithm was by itself, you can do that. We can rewrite into exponential form. Okay? Now, how do we solve for x? How do we get rid of that square root? We square both sides. So we have e to the 10th equals x minus 8. So with your calculators, you can take e to the 10th, and then to solve for x, what are you going to do? Amarissa, that is a great question. Sorry to eavesdrop. Amarissa was asking her pod members, would you be able to square both sides first? The answer is no. Since the square root is inside of the logarithm, you have to take care of the logarithm first. Then, once the square root is by itself, then you can square both sides. Okay? What? If you square both sides from here, you'd have 25, not 10.
Yeah, I'm not feeling very, not feeling that, but I have my either that equals x minus 8, and I know I just put the and then x squared and then x.
Oh, yeah. In your calculator, you mean? Yeah, it's going to be the same. So what do you get when you take e to the 10th and then we add 8 over to isolate x? 22,034? 466. Okay, we knew it was going to be big. E to the 10th, probably a big number, right? Yep. All right. Okay. When you look at the list of strategies, what is something that we should do to the left side? We should condense that left side. Okay? If there is more than one logarithm, you need to either squish it together, or if there's one on each side and they're equal, then you can use the one-to-one property. But we don't want two logarithms on one side of our equation. So since this is subtraction, we can write this as log base 2 of x over x plus 1 equals 2. Now, do we have one logarithm by itself? Yes or no? Yes. Which means we can do what with our equation? Okay, we can change form. So we can say 2 squared equals x over x plus 1. Okay, 2 squared is? How do we solve something like this? Jackson asked, can we multiply the x plus 1 over? I think that sounds pretty reasonable. 4 times x plus 1 gives us 4x plus 4. Which means 4 equals negative 3x. And x is negative 3/4. No problem. Thanks. X is negative 4/3. No one has an issue with our answer? Amanda, what's your issue? We cannot have negatives inside of our logarithm. Negative 4/3 makes both x and x plus 1 negative, which means this cannot be plugged in to our original problem. There is no solution. It is super important that you check to see if your answers can be plugged in before you can go, or before you determine that that's your answer. Okay. Okay, we have 1 minute until I'm supposed to release you for lunch. What I'd like you to do is write down this problem that we're going to do after lunch. Okay. What's the issue with this problem right here? They are not the same base, and there is not a way for us to write them the same base. So I'm going to show you a trick to solve this that you have not seen before. And then once we are done with this trick, then you guys will work on problems together. Okay? Go to lunch. Okay, we decided that this one was going to be tricky because we have two different bases where we cannot take one and write it as the other. If that were 2 to the x equals 4 to the x minus 1, we could rewrite 4 as 2 squared. But 3 and 4, there is no way to write those as the same base. Okay? So we are going to make this a logarithmic equation. How do we do that? If we do something to one side, we have to do it to the other to balance out. Do you agree? Okay, so if I make this the natural log of 3 to the x, and I make this the natural log of 4 to the x minus 1, did I do anything illegal? Our equation just looks different. Okay, if I did something to one side, I have to do it to the other. Okay, now, keep in mind, this is only out of desperation because our bases can't be written as similar bases. Okay, if we have exponents inside of our logarithm, what can we do with them? What'd you say, Gabe? Okay, so we can take our exponents and write them in front of our logarithm. Okay. We have two x's in our equation. We really only want one, so we can get x equals, okay? So what I'm going to do here is I'm going to multiply that x minus 1 to the natural log of 4. So we have x natural log of 4 minus 1 times the natural log of 4. I just took the x minus 1 and multiplied it to the natural log of 4. Now, there are two different places where I have an x in my equation. So what I'm going to do is I'm going to group those together. Okay? So I'm going to take x natural log of 4 and I'm going to subtract it over. Why did I do that? What can be done now on the left side? What? Not quite. Yet. Not yet. Is there anything in common between the two terms on the left? They both start with x, which means can we factor out an x? Since we had two terms with x, we could put them together, factor out the x, and now to get x by itself, what can we do? We can divide that over. Okay. We had two terms with an x, we put them on one side, factored out that x, and divided the rest over. You should get 4 something, I think. $4.819. Yes, no, yes. Okay, so we're going to do more examples, but instead of me doing examples while you write them down, you and a partner are going to work on examples. At the end of this activity, your gold sheet can tell you what your homework is for tomorrow.